Thank you everyone for coming out. So today we're going to be talking about piloting around the rocks, avoiding threats in Kubernetes. My name is Robert Tonic. I'm a security engineer at Trail of Bits. And with me I have Stefan Edwards. He is technically my boss, and he is also the assurance practice lead. So if you're interested in assessments, talk to him. Someone who unfortunately couldn't make it today is Dominic. He is also a security engineer at Trail of Bits. He worked closely with me and was my counterpart on this assessment. He's unfortunately not here because of another conference, but figured we'd include him anyways. So we're going to go through a quick disclaimer. So even though we perform this assessment, we don't use Kubernetes every day. So we have the majority of our knowledge related to core Kubernetes, so not including CNIs or CRIs, those types of things. And there might be third-party mitigations for a lot of the things that we talk about, but we're trying to scope things specifically to Kubernetes. As a quick outline, we're going to give you some background on the assessment. We're going to go through what trust zones are, and then we're going to talk about some of the architectural concerns that we found within the Kubernetes assessment and what those look like. And then we're actually going to discuss how you can use the processes that we followed to threat model and review Kubernetes within your own environment. And this also applies to things that are not Kubernetes, but we're going to use Kubernetes as the example.
Also, too, one of the things, we tried to keep this talk short. I'll just yell, it's fine. We tried to keep this talk short so that there'd be time for questions. We can go over templates, we can do whatever, we can walk through the accoutrements that we had put together for the report. So if you do have questions about things, if you wanted to yell at us about something that we missed or anything like that, we can save time for that at the end. So we made it a little shorter in order to give time for that, because I think that's more interesting.
Yep. And on that note, I'm going to hand it off to Stefan, and he's going to give you some background on the assessment.
Is it better with this? Yeah? So I think one of the more interesting things is what we were actually attempting to do with the report itself, right? I think quite a few people had a different view of what we would be doing, what we'd be looking for. Our mandate from the CNCF was actually to find low-hanging fruit and new bugs. So we couldn't just scour GitHub issues and report them in our report. We had to look for new, non-trivial things that we saw, but that were more of the obvious case, right? So we all can pick on, deployers, or we could set up something insecurely. That was not the direction we were supposed to head with this. We were supposed to find new code and design level issues that we saw either through discussions with developers or with actually just Bobby, myself, and Dominic reading through the Kubernetes code itself. And then we were meant to evaluate the assumptions and the design decisions that Kubernetes has put in place. Many of these design decisions that Kubernetes has made are not necessarily the ones that you would make when you were rolling this out in your environment, or if you were developing these things yourself. So we really wanted to go through and document the design decisions, the assumptions, those sorts of things, so that when you're taking the threat model, when you're looking at the inherited controls that Kubernetes has, you understand what assumptions and what design decisions were made whilst writing it, and then you can understand how to apply it to your environment. Now, if you're using this in GKE or EKS or any of those sorts of things, it's obvious that there's a set of inherited controls. But if you're running Kubernetes on premises, if you're standing up your own clusters, if you're doing these sorts of things, you really have to understand the threat model that Kubernetes itself, the design decisions that they made whilst writing it, in order to understand your own threats and your own risks and which controls you want to put in place and policies and those sorts of things. And then lastly, we read a lot of documentation and a lot of configuration options. And Bobby took lead on this. We actually put together, and we'll discuss what it is, a white paper on ease of use with Kubernetes itself. You can hit the next one. Next one. Is it not? Is it not shifting? This is how hard it is to mess up. We can't get Chrome to work. There we go. So what did we actually do? I mean, quite a few people here have actually read it, but we had 37 what I call technical findings or source level findings. These are things that range from integer parsing bugs that allow us to bypass policies to issues in core DNS and other things that came out. These are the assessment team sitting down, reading code, running Kubernetes, and looking for edge cases that we thought were problematic. Those were the technical findings that we had there. And then we also had 17 of the paper exercise threat modeling sorts of findings. And interestingly, as I mentioned, for those of you who came in towards the beginning of the talk, before I started, I mentioned that I actually have released all of my notes. So all of my discussion with the etcd folks, all of my discussions with the various teams that make up the special interest groups that make up Kubernetes, those notes are all open source. So if you're interested in the discussions and the commentary that came during the threat model, you can actually just see the raw developers' notes there in GitHub itself. And these were obviously mostly design-related problems. I don't think they're surprising to most people who have run Kubernetes before or who have looked at the edge cases, but there's a number of interesting discussions that came out. And I think Aaron Small, who may be floating around, he gave a talk earlier, and I think that was the interesting part. And Aaron always said this. The really interesting things are the templates, are the developers' notes, are those sorts of things, for the threat model at least. And then, as I mentioned, we also released a white paper on the ergonomics of Kubernetes. So basically, where do we see things that are hard to use, that are surprising to us, and how to avoid those sorts of things? And Bobby took point on that one. You can go, Bobby. So, I'm sure, because there's such a large threat modeling crowd here, we've all heard of trust zones, right? Most folks are familiar with these sorts of things. Yes? So, we're going to go through basically, I'll talk about what trust zones are for those folks who haven't worked with trust zones, and then we'll talk about the ones that we actually put in place for Kubernetes itself. You can go. So, if you're not familiar, a trust zone is basically a logical grouping of components and then controls that sit at the boundary there. They may sit in other locations, but mostly we're concerned about those sorts of boundary edges. And we want to group these components, we want to group things together so that we can do other activities against them. We can do control analyses, as you might see in the Kubernetes threat model. We can actually understand which actors, which location, which policies need to be applied. And if you threat model, you are familiar with all of these activities. You may call it something different. I've heard these called logical boundaries. I've heard these called many other different things. But basically, we're looking for logical groupings of components, of controls, of data, of actors that we can put together and then group them and discuss them. And this is something similar to, if you've read the threat model, you'll see etcd is in a master control data zone, if I recall correctly, was the term we gave it. And we wanted to be able to discuss where etcd should live, who should be able to talk to it, what sorts of auth-n and auth-z controls we should have, those sorts of things, and really analyze where etcd should be, who should have access to it, and what sorts of controls at a design level that we can have. And then, obviously, these can be nested, right? There are certain components within Kubernetes that may live on the same host as Kube API server, but are not logically of the same permission as Kube API server itself. So think of CCM and KCM, of controllers, of admission controllers, webhooks, those sorts of things. They have different permissions. They have different access to data. And logically, we want to analyze and discuss those controls there for those different components. So we group them into trust zones. Hit the next one. So there's many small components, as I mentioned. And so trying to analyze each one of these would be hugely problematic. Can anyone think of how many components are actually in Kubernetes, like off the top of your head? We only had a handful. We did not, if you read the report you've seen, we did not actually have all Kubernetes components. There was a focused set of things that we were interested in. And even with that, we ended up with hundreds of pages of issues, of documentation changes, of code things that we were interested in discussing with the team. So a small number of components can lead to a large number of findings, of analysis, of all those sorts of things. So we wanted to group them logically. And in order to do that, we actually started with a data flow diagram. There were several nascent data flow diagrams previously, and so what we actually started with was, if you look at the repo, I started with a graph viz. I sat down, I looked at Kubernetes, I ran it with Bobby, we figured out how things connected, and we started to work on this data flow throughout, from me running kubectl all the way through to etcd to see what talked to who and how. And when we broke these components down, we talked about the actors and all those sorts of things that you would normally do in threat modeling itself. You can go to the next one. So this is the version that ended up in the actual report. It elides certain information because obviously Kubernetes has a large number of components, a large number of protocols, but we wanted to capture the main portions of actors that we would see here. As you see, we have an external actor, we may have an administrator in the middle there, some user who has to deploy something, and then an internal attacker who had transited from an internet zone internally. And then we broke down the components into various trust zones and annotated their connections back and forth to things. So we were very curious as we were going through what's talking HTTP, what's using TLS, what's using gRPC with insecure connection or not, and breaking down this data flow and discussing what was using IPC, all those sorts of things helped us understand design decisions and understand controls that we expected to be in place there. Does that make sense to everyone? Perfect. You can hit it. So, as most people who have done threat modeling are aware, the whole reason why we care about trust zones is to then understand what happens if they break. What happens if I, as an external attacker, have transited an internet zone and now am an internal attacker with pod access or something of that nature? What can I do? What's the actual criticality of this zone? What sorts of data does it process? What can I do with these sorts of things? We're really interested in what happens when these things fail. And so in processing these sorts of trust zones and breaking things down and talking about connections, we really started to dive into the internals of Kubernetes itself. So one of the things that we found, if you read the technical assessment, is that there are credentials stored by default within pods. And so when we were going through the threat model and discussing these sorts of things, we really did have an actual scenario there. It wasn't like, well, what happens if you get it? It wasn't a tabletop exercise. We literally were looking at credentials. So now what can I do with that? How can I parlay that access? That sort of criticality became very real. And so if you've done threat modeling, it's kind of the ideal scenario. You don't have to come up with a what if. It's literally, we're looking at this credential here. I am now an internal attacker. What can I do? And that sort of criticality is extremely important for Kubernetes. Obviously, we want to know how these things fail, but then it's also important for you as you apply the Kubernetes report to your own environments. Sure. Okay, and I'm going to hand it back over to Bobby.
Sure. So once we actually built out some of the trust zones and we analyzed some of the data flow, we were actually able to then meet with the different special interest groups and discuss our assumptions versus theirs. And we were also able to begin analyzing the source code. Now, this was all done mostly asynchronous, so a lot of things were happening at the same time, but it was a very bidirectional communication flow. So I was working with Stefan closely, and he was working with me closely, so that we can get all of those concerns sussed out. But we're going to actually go through a few that we found in Kubernetes itself. So, actually that went way too far.
You jumped ahead one.
Yep. Cool. So policies. When we were going through the threat modeling, we asked ourselves, how do policies actually apply, right? Because there are different levels that could affect policy, cluster configuration, as well as at runtime when you're using kubectl to try to apply these policies that should propagate. What we found was in certain situations, these policies can be ignored. On the pod security policy side, if you don't have the admission controller enabled, then even if you make that particular configuration, it might not stick. Well, it actually won't stick if you don't have that enabled. On the network policy side, certain providers don't necessarily adhere to whatever you define. So you could basically apply a particular policy, but it might just be ignored. And there isn't any particular warning to tell you if either of these things are occurring.
Yeah, it was interesting. So TM01, the first threat modeling finding, it wasn't a discussion finding. This was me trying to figure out how Kubernetes works so I could actually understand things and reading the documentation. And there's a little note, a little footnote in the network policy documentation that says, depending on which CNI you choose, you may not actually have a network policy applied. And I was like, well, that's curious. And so we led to other areas that we found other policies that just fail silently. So Kubernetes will parse them, it will attempt to apply them, realize that there's no applicable objects that it can operate on, and will not warn a user, or previously would not warn a user for those sorts of things.
Yep, and then once we started to look further into the actual pod security policy, we actually found that there was a documentation discrepancy. So allowed paths effectively are supposed to prevent pods from mounting specific paths on a given host. However, there are ways to bypass this through PVC mounting. So if you have a persistent volume that is of type host path, you'll effectively get the same functionality. It's just a different method of like mounting. So it's effectively the same thing, but that's not actually covered by the allowed paths on the pod security policy. So the documentation wasn't exactly consistent. Now, when we actually look at like TLS, most components accept inbound HTTP and don't strictly enforce HTTPS. Now, even the ones that do, the TLS connection isn't secure, so they won't necessarily verify hosts and things along those lines. And then when we actually look at deploying with certificates and similar, Kubernetes doesn't natively support certificate revocation. So if a certificate is compromised and you have to rotate it, it might not be as trivial as one might think. And then secrets, one of our favorite things. So secrets aren't encrypted by default at rest. So you have to effectively configure a provider to do this for you, and that configuration might not be as trivial as you would think. And what we found was some of the documentation was also slightly misleading as far as like which ones to use. When we actually look at other areas where secrets might be, we took a look at the logs, and we found when we enabled debugging at higher levels, bearer tokens were just dumped, and that was actually a problem with a third-party dependency. So little things can kind of creep out. And then finally, looking at environment variables. Some of them to actually configure the underlying cluster, so like API servers and similar, accepted potentially sensitive environment variables for configuration. So I think at one point there was like an SSL configuration that accepted a password. So,
just out of curiosity, of people in the room, if you found a developer was passing around secrets, passwords, keys, any of that sort of thing, how many of you would enter a finding against that application for doing that? So if you actually look at how Kubernetes does this, there's multiple different mechanisms by which it passes environment variables. In fact, it was very interesting to look through the code for those sorts of things. But there's a number of locations that just assume that the box is locked down, therefore environment variables are okay. And this may not be the same design decision that you would make in your environment, since a vast majority of the room said that they would enter a finding against a developer for that. Here, sorry.
So the key takeaways for this was that Kubernetes is large and complex, both in design and implementation. There's a lot of code and there's a lot of components. And when we actually look at the security controls that are available, most of them are pretty minimal in like the default deployment of Kubernetes. You can add a lot of things with third-party additions, but by itself, it's pretty bare. And that cascades to the effectiveness of a lot of the controls that you might implement, right? So if you accidentally forget to enable an admission controller, that might be really bad if you don't test for both the positive and the negative effects of a pod security policy, for example. Or network egress, right? You think that you have a policy there, but it's actually not. And then finally, documentation doesn't always match expectations, so you really have to be proficient in what you're trying to enable so that you can actually ensure that it applies the way that you expect it to. So with that in mind, we're actually going to walk through how to review your environment in 6 easy steps. So first of all, it's evaluating your component data flow, right? You want to identify inbound and outbound connections, the protocols that they speak. You want to identify components that have nests. And you also want to look at actors, right? Who is in your environment using your applications? Then, once you have that, you want to actually define some of those trust zones. Identify the controls, the policies, all the placement information that you have related to those components so that you can then start to identify interaction requirements. So does one component need to talk to another? What are the failure modes of that particular component, right? And then once we have that, we're able to go through and determine criticality. What would happen if a zone interaction were to stop, right? Would other components fail? Would it potentially cause workloads to fail? And then we can actually look at some of the security implications of this, right? So the first one has like denial of service stuff, but specifically if we have a component that stores sensitive information, that might be a way for an attacker to get some more leverage on the cluster. Or if that particular component has access to other things that the attacker previously didn't have, that might be a way to pivot through. So all of these things matter, especially with placement, right? So if we take into account those first two things, resource exhaustion, right? One component might use more resources than another. And if one could influence the other through resource exhaustion, that could be a problem. And are there certain locations that components just shouldn't run on, right? Should the etcd server run on the same hosts as most of your workloads? That may be concerning. And then you actually want to discuss these assumptions, right? So after you've gone through, you've identified the data flows, you've built out some of the trust zones, you actually want to talk to the teams that manage each of these zones because there's a lot of knowledge that might not be in documentation and your assumptions might be incorrect. So going through and identifying those inconsistencies and documenting them is important. And you can also then use those meetings to actually confirm that the data flow and the zone definitions are complete. Because you might have something that is correct, but not complete. And then when you actually go through to confirm these assumptions, so you can go through, review your notes, review the documentation, review all the assumptions that each team made, you can actually then look at the source code, right? This is a very targeted approach because instead of just looking at random places, you can look at the most critical components where a lot of the teams think that there could potentially be problems that might not even be documented. And this could be failure modes, this could be component dependencies, so on and so forth. And then finally, the most important part is remediation. This is the part that is really tough. But trying to make short and long-term goals for remediation is important, right? Because you want to fix the problem instantly, especially for the high criticality ones. And then long-term, you also want to have rock-solid goals to preventing it from ever happening again. And then ensuring documentation reflects that is extremely important. Because if you make these changes and the documentation doesn't reflect it, then the next time you go through this, you're going to have more discrepancies. And then finally, consulting with each team across all teams to discuss the findings, even if it's not related to the zone that they specialize in. Fixes to some of the problems in other zones might impact a variety of other components. So, in summary, threat modeling doesn't necessarily have to be complex to yield results. A lot of these meetings were relatively quick because it's surprisingly difficult to get open source developers to come together and chat about the stuff that they like doing. Source reviews can also be more targeted when you pair it with threat modeling, right? We're not running around trying to look through a million lines of code, just randomly looking for problems. And then finally, it also helps you improve not just your security, but also your documentation, your design, your implementation, right? As you're going through and confirming in source, you can identify areas that have code smells. You're also able to identify components that might not be necessary, right? And then of course, ensuring documentation is up to date. Like that's a big one. And to actually help you do this, our threat model has several components in it that can help you. So first of all, an appendix with a rapid risk assessment template that we used to discuss all of these things with the special interest groups, a example cluster data flow, example cluster trust zones, and some example findings. And by example findings, I mean these are actual findings, but you can just use them as a template. So. And with that, we have some resources. So I want to give a huge shout out to Aaron Small, Jay Beal, Craig Ingram, and Joel I forget his last name every time. I'm so sorry, Joel. So yeah, they basically were our clients for this assessment, and they were absolutely awesome. I would definitely suggest going and looking at the talk that Aaron Small and Jay Beal gave. It goes over a lot of the things that we did not discuss. Now, you won't be able to see it this KubeCon because I gave it yesterday, so if you weren't at that talk, you can't go back in time. The repository with all of our notes is the audit Kubernetes under the Trail of Bits repository sets. That has all of our notes, the raw rapid risk assessments, and a bunch of other fun stuff. So if you actually look at the GitHub issues that are closed, you'll see all of our discussions about a lot of the findings. So, Joel Smith. There we go. The final reports you can actually find on the Kubernetes community repository. And then the last two links that we have here, one is attacking Go. We recently released some of the basic tools that you can use to attack Go systems. And then understanding Docker container escapes, that was written by Dominic. And that was an awesome analysis of one of the random Twitter one-liners that allowed you to jump out of a privileged container. So some interesting things to think about as you're going through and thinking of potential vulnerabilities. And then finally, if you want to talk to us on Twitter or just say hello, you can find our handles there. So awesome. So I think we'll open it up to questions. Cool. Say again, sorry? So she asked, what is the recommended approach for secrets? And this highly depends on the environment that you're running in, right? I think as far as compliance standards go, there's a lot of implications there. In general, I think the documentation is now updated to reflect best practices. So if you were to go to the official Kubernetes documentation, it will actually give you a list of potential providers that you could use and configure, and I would probably go with that list. Back there on the left.
So you talked about that kube secrets without encryption at rest were dangerous. Were there anything else about secrets that you found interesting or anything that we should pay attention to in the future?
So secrets management has always been tough. I think as a whole, recommending the use of some sort of KMS to manage a lot of your secrets, your certificates, and things like that will be incredibly useful, especially for doing things like managing the underlying cluster infrastructure. So if you use an OCSP server, then you're able to revoke certificates a little bit easier. And I think HashiCorp Vault has support for this. And in general, just trying to offload it to something that does it better than any one of us could implement ourselves. So I don't know if that answers your question, but.
So your 6 easy recommendations there. It was kind of unclear whether you're saying that we should go through as ourselves and do our own threat assessment of Kubernetes as a whole, or the components that we're running under Kubernetes, or our own code running under Kubernetes. I definitely the last of those. And absolutely some of the components, but that was a little unclear.
Sure. So I think what you should take away from this is not to go through and try to, we reviewed something like 2.7 million lines of Go. So I don't think most organizations have the ability to go through and do that much. I wouldn't even say that we scratched 10% of that meaningfully. So no, I don't think you should go through and do a threat model of Kubernetes itself. What I do think you should take away from this, though, is that there are certain inherited, if I give you a Linux box and I say, please configure this, you're going to say, I need SE Linux, I need some, etc. What we attempted to do is, hey, these are the inherited controls you get from Kubernetes. These are the things that you need to bandage over, these are the things you need to configure, and now you have your set of inherited controls when you're using Kubernetes itself. Does that make sense?
Yeah, no.
Yeah, and does it answer your question? Okay.
Awesome.
We have that gentleman with the, mirror, yeah, okay. Sorry, mirror shades.
Second question.
Sure.
So maybe perhaps dig a little more. The gentleman asked, what other issues did you find for secret management? So one thing we know is secrets are namespace specific.
Mm-hmm.
If you are running 2 pods in one namespace, right? If you pop one of them, you can
Sure. So I think that comes down to ergonomics, right? So the question he asked was, if you have secrets in a namespace and you have two different types of pods and one of them gets compromised and it potentially compromises that particular secret, that could be a problem. But this kind of encapsulates a couple of problems, right? Because first of all, namespaces should be application specific. So if one pod is running something else, then technically you have, I don't like calling it this, but for lack of better terms, like multi-tenancy in the same namespace in respect to the actual workloads, right? Because you have one pod doing one particular thing, and then another pod doing another particular thing. And if they both have access to the same secret, then if one gets compromised but the other one doesn't, then, well, you still have the problem of broken secrets. Is that what I am understanding correctly? Okay, so, right, totally. That's why I was trying to break that down a little bit more. But, okay, so the quick answer to that one is namespaces should ideally have one set of applications that encapsulate. Like you shouldn't mix like, you know, web application A with web application B in the same namespace unless they are logically, like, they should logically be together or depend on each other. So. Okay, so what he asked is, do these findings apply to GKE? And I'm going to do just a blanket discussion on this one. So managed providers are very different. Probably the person to ask would be Aaron Small on this one. But in general, managed providers tend to differ in how they actually manage each of the components of Kubernetes. So it's really difficult to say whether or not they actually affect GKE or whether they don't. I think Aaron actually released a blog post discussing that as to whether like certain findings affected GKE and how they handled that.
So GKE actually went through the entire threat model and the technical assessment and discussed which ones apply to them and which ones do not, and how severely. So you actually can review that. We can find it right after the talk if you're interested in that. Sure. There. Sorry.
So I mean, does this threat model kind of use anything that the developer of an app, right, which needs to deploy those containers, needs to understand, right, as they are threat modeling their own applications?
So the question is whether or not this process needs to be known by the developers. So if I'm understanding correctly.
Developers of the applications themselves.
Okay.
To deploy them.
Okay, so the developers of the applications that are going to be deployed. Okay, so they could easily, right? So typically, this is a process performed by people who are interested in security, mostly because a lot of times what we're trying to do is quickly go in and identify what the developers did and where they did it and how. So we don't necessarily want to encumber them with all the documentation related to this, right? Because we're trying to identify the best place to potentially attack something. And conversely, identify the places that need to be defended more. So with that mindset, technically the developers don't need to, right? If you're coming in and you're going, okay, we're about to release a new version and we want to identify what differences there are between the last version and this version and how this affects the previous set of documents that we produced using this process. And the idea behind this is to be relatively quick. We don't necessarily want to bog them down with 8-hour discussions about every granular control. Like, that's not something that we want to do in this process because that's, while it is effective for certain organizations, it might not be effective for most, especially the smaller ones. Because realistically, you can't pull a senior dev from a team and sit them down for 8 hours and then just go through all of this stuff because that's like an entire day wasted. So nobody really wants to do that, and plus, it's really boring. So this is a much more informal method of doing a risk assessment, which is why we kind of modeled it after the RRAs. So it was much more, it was approaching the ease of usability versus necessarily depth.
Are there any risks that can only be mitigated through third-party conditions or external applications?
I think, so the question was, are there any risks that could only be mitigated through third-party plugins or applications? And that's kind of a tough one because some of the risks are actually presented by the third party, right? So if we actually look at the CNI itself is just an interface, but the provider is what gives it its functionality. So if that functionality is is abusing a certain thing, right? Now you need a third party for a third party. So it's really tough to tell. There probably are though, like to get back to your specific thing, but off the top of my head, there are a lot of components and yeah.
I do think one control family that is a little bit more lax in Kubernetes itself, even if you tune it up, is audit. At least within the version that we were looking at, auditing controls. Now, there's plenty of logging. I'm sure have all seen our Splunk logs or Sumo Logic or whatever explode with Kubernetes, but specifically this user at this time undertook this action with this thing on this component is not something that is universally applied across Kubernetes. So that is something that very often you have to reach out to a third party or do your own investigation yourself. Sorry.
And also to kind of complement that, something that he kind of glossed over in that answer was actually authn and authz. Authentication and authorization is pretty tough. There's tons of third-party things that help you do this, and Kubernetes itself doesn't really help you do this in any real impactful way. So.
Just one more.
Were there any things that you found particularly surprising, as in like they did a surprisingly good job about securing one component, or any components that you felt were surprisingly bad, like you just couldn't wrap your head around how they could have thought that was a good idea?
No comment.
So I think it's easier to go with surprisingly bad because that's kind of what we were focused on, right? And I wouldn't even say surprisingly bad because that sounds like we're bashing the developers, and that is not our intent. What our intent is to identify areas of improvement. And specifically, I think the kubelet is probably the area that I would suggest improvement. And that's mostly because there were lots of subtle interactions because the kubelet is interesting. It interacts with the host, right? And because it interacts with the host underneath it, it has interesting implications. So, for example, we found a problem with command line parsing. So the kubelet depends on Ionice, and if Ionice faults or something, it will just bork the kubelet. And then another one was actually the TalkTow that Dominic found, where there was a problem with how they hard-coded links to Docker PID files, I think it was, in procfs, and that caused some potential areas where if an attacker has like an unprivileged host access but root container access, they can use that to elevate permissions. So and integer overflows. Yeah, there were tons of those. In fact, Nico Waisman from Semly?
Well, he's now at GitHub.
Yeah, now at GitHub, they got acquired. He used their technology to actually go through and find all instances of the potential like downcastings of integers from like dynamic type widths to fixed type widths, and that was pretty interesting.
So I assume that you already find issues for those bugs.
Yes, in fact, Craig Ingram, he created a GitHub issue that has a bunch of links to all of the filed issues. It's not in here, but if you Google it, you'd find it. I actually feel like it might be in Aaron and Jay's talk, so you might want to check their slides. But I think, yeah, if you have any further questions, please contact us outside. Like, we'll stay around, we can chat for a little bit.
Yeah, we're not.
But we're a little bit over time, so.
Are we over? Yeah, perfect. Thank you very much, everyone.